So yesterday we did factor tree, in which we were making the branches till we get the prime numbers over at the end of the branch. Today we will
Yeah.
learn another method of factorization. Let's suppose I need to do factorization of 64. So I will write the 64 like this and will make a division. Now let's start with number 2. 2 is my first prime number. So I'll start with 2. 2 times 3 is 6 and 2 times 2 is 4. So 32 times 2 makes 64.
Yeah.
So this is how I will do. Then again 32 can be done by 2. So 2, 16. 16 times 2 is making 32. So in cross it should be there. 2 and 32 making 64. 2 and 16 making 32. Then 2 and 8 are making 16. Then 2 and 4 are making 8. 2 and 2 is making 4, and then 2 and 2 makes 2 and 1 makes 2. So we will leave this table whenever we get 1 over here. So these are going to be my prime factors, and this method is known as prime factorization.
Yeah.
So there are basically two methods to find the prime factor. One was that tree and another is this prime factorization. This method is like most commonly used in the higher classes, prime factorization. The tree method is for initial learning, that you understood how we are creating the branches. But later on, as you will proceed in your later classes, this method is more prominent. Although the things are going to be the same. In that also we were making the factors with the prime numbers by 2, then we were trying with 3, 5, 7, like that. Same here.
Yeah.
Like if I give you a number, let's suppose 128. Try this by the prime factorization method.
Two 128. So 64. So again, 2, which is 32. 2. And then, which is 16. Eight. And 2. Okay. So the prime numbers are on the left-hand side, right?
Yes, they are on the left-hand side. Like you have done this question, right?
Yes.
I will do it also on the board and then just cross it check. 2 times 6, 12, 2, 4, 2, 32, 2, 6, 2, 8, 2, 4, 2, 2, and 2, 1. So 1, 2, 3, 4, 5, 6, 7 2s are there.
7, 1, 2, 3, 4, 5, 6. Wait. Oh. 7.
Yeah, 7. Are you getting more or less?
There's 8 on the screen and on my book.
8 on the screen. 1, 2, 3, 4, 5, 6, 7. Don't consider this one.
Oh, okay, okay.
Here I got the 1.
Oh, okay. Then yeah, 7. Sorry.
7? Okay.
Yeah, 7.
Okay. Try one more. 625 by the same method, prime factorization.
625. I'll do by 5 because the number ends by 5, so it's divisible by 5.
Okay.
120, 100 answers. Five, 10, 20. I have 4 5s.
Perfect. 4, 5 is correct. So now I think the factors, prime factors, and everything is clear.
Yeah.
Okay, one more thing that I would like to ask, if that is clear, then I will move to the multiples. Let's take a small number, let's 24. Tell me its factors and its prime factors, both the things separately.
Okay. I'm confused with factors.
Confused with factor. Okay. Prime factor done?
No, not yet.
Okay, do them, then I will let you know the factors.
Okay. Oh, now I got confused with both of them because of the two methods.
Okay, that's why I have given you the question. I want to see whether you have confusion or not. See, first I will talk about the simple factors. Then 1 times 24
24.
times 12.
24.
Yes. And then with the 3 also it is going 3 times 8
Yeah.
times 6.
Yeah.
Then with 5 it will not go.
No.
And then if I try with 6, then it is repeating. It will come 6 times 4. So when the repetition
Yeah.
starts, we just stop over there. And these are my factors. 1, 2, 3, 4, 8, 12, 24.
Oh, okay.
Now the prime factors. For prime factor, I am using the prime factorization method. 2 times 12, 2 times 6, 2 times 3, 3 times 1. So 2 multiply 2 multiply 2 multiply 3 are my prime vectors. Prime factors are always the prime numbers, and all of them together on multiplication give me back my number. But the factors are individuals. They can be prime number, they can be composite number, and together they are not going to give me the number. Any of their combination will give me the number. Like 1 and 24, 2 and 12, 3 and 8, 4 and 6. Combinations are giving me the number. Now it's clear between factors and prime factors?
So factors is just all the numbers.
Yes, factors is just all the numbers, and prime factors are the prime numbers which together on multiplication give me the number, the given number.
Oh, okay.
Okay, now try one question in which both the things you need to tell me, factors and the prime factors. Clear?
The same question.
No, a different number I am giving you. The number
Okay.
is 40. Factors and prime factors, both things.
Okay. So the prime factors are, wait, I did divided by 2 for prime factors.
Okay.
So I did like the method that you just showed me. I did 2 and then 40 and then 2 and then 20 and then 2 and then 10 and then 2 and then 5. Do I put a 2 next to the 5?
4 into 5, that one you did? Oh, sorry. Not 4 into 5, 4 into 10, right? Then 5 into 8. This much you did?
No, I did 1 times 40,
Hmm.
2 times 20,
Then
2 times 10.
2 times 10 will be 20. We need 40 from the combination.
Oh, so yeah, 4 times 10. And
yes, keep on
8
checking with
times
every
5.
number. Don't directly jump to 8. 1, 2, then check with 3. Not going, then 4, then 5, then 6, then 7. Then when you come to 8, you saw that it is repeating. When 8 comes, it is 8 times 5. So that I have already included 5 in it. Then you can stop over there and you can consider these to be your factors. Okay?
Okay.
Now tell me the prime
So
factors.
8, 4, 2, 1. And then the factors are 1, 2, 4, 5, 8, 10, 20, 40.
Perfect.
You wanted to show
Prime
me
factors.
multiples.
I want you to tell me prime factors now.
Yeah, 5. I mean, yeah, 5, 4, 2, 1.
4 is not a prime number. In prime factors, only prime number can come. Check again.
5, 5, 2. 5 and 2, yeah.
No. You have to do it completely like this for prime factors, na? 2 times 20, 2 times 10, 2 times 5, 5 times 1. So these will be my prime factors. Got it?
Well, yeah, that's what I did, and you said it was wrong.
You said 2, 4, and 5. But you
No, when I was saying the numbers for the method, when I said 2 and 10, you said it's 4 and 10.
Here, that 4 and 10 is this one. When we were talking about the factors.
Oh, wait, I'm confused.
Yeah, these are about the factors, and this is what I did is prime factors. Two different things.
Oh, okay.
Okay?
Yeah.
Okay, just one more question just to make sure that now you will not get confused. So the next number is, let it be a simple one. We can take, okay, 28.
I'll do the prime factors first.
Both the things, factors and the prime factor.
Okay. So the prime factors are 7, 2, and 2.
Okay, perfect. And the factors?
And then, let me just get them.
Yeah.
8, 2 times. More. So the factors are 1, 2, 4, 7, 14, and 28.
Just a minute. Let me write them.
Yeah.
We,
4.
3 will not go 4. 4 will go with
7.
And then 5 will not go, 6 will not go, and then 7 repeating. Yes, 1, 2, 4, 7, 14, and 20. Perfect. Now it's all clear?
Yeah.
The factors and the prime
Yeah.
factor. Okay.
Yeah.
Now we can switch to the next topic, that is multiples.
Okay.
Multiples, like factors, you have seen that they are always less than the given number or equal to the given number. If I talk about the number 14, so its factor will be 1, 2, 7, and 14, right?
Yeah.
So all the factors are either equal to 14 or less than 14. And they are completely divisible. Now, what happens in the multiples? In multiples, the given number increases. How it increases? If I'm talking about 14, then the multiples will be, first multiple will be the number itself, 14, because it is 14 times 1. Then the factor of multiplying with 2 comes, 14 times 2, 28.
28.
Then 14 times 3, 42. Then 14 times 4, 56. Like this, it will go on. So these all are said to be multiples of the given number. Now factors are always less than or equal to a given number, but multiples are always greater than or equal to given number. They are never less than. Multiples cannot be less than the given number because we are increasing the number for the multiple. We are multiplying it with some factor. We are multiplying it with 2, 3, 4, 5 to get a new number. So multiple is
Yeah.
always greater than the given number. Second thing,
Okay.
factors are finite, means they are fixed. If 14 is going to have 4 factors, then yes, it will have 4 factors only. But the multiples are never fixed. They are infinite. You can keep on multiplying the 14 with some number and you will get more and more multiples. Right?
Yeah.
So multiples are not finite. They are infinite. Okay? And the third point about the multiples is that multiples are multiple of itself. Means if I am talking about the multiples of 14, then 14 will definitely be a part of it. Because 14 times 1 is 14. Any number to be multiplied with 1 is multiple, the number itself.
Yeah.
Okay. Now if I ask you to write first 5 multiple of 6, what it would be?
6, 12, 18, 24. 6, 12, 18, 24, 30.
Yeah. So this is how you can tell me any number of multiples. Okay, this is all about multiples. Yeah. Now, prime and composite number is also clear to you, na? Yes?
Yeah.
Okay, let's do some questions. Let me share them. Here they are. Can you see the question number 2? State
Number
whether
2.
the following statements are true or false.
Oh, yeah.
Okay, first part. The sum of 3 odd number is even. Is it true or false?
False.
Sure?
I don't get the question.
They are asking sum of 3 odd numbers is even. If I take any 3 odd numbers randomly, any 3 odd numbers.
3?
Like 1, 3, 5, 7, 9, they all are odd number.
Yeah.
So take up any 3 odd number and add them up. Whether they are giving you an even number or odd number. This is what they are asking.
3, 7, and 5, for example.
Okay, for example, 3, 7, and 5. Add them up.
15. It's an odd number.
So that means this statement is false.
False, yeah.
Next, the sum of 2 odd number and 1 even number is even. Now try this with any example.
7 and 3 and 2. Yeah, it's true.
Good. Next, the product of 3 odd number is odd.
Yeah, 3, 7, and 9, 19. So it's odd, yeah.
Not sum. They are asking for the product.
What does that mean?
Product means multiplication of any 3 number.
Oh, 3 times 5, 15. So the product of 3 odd numbers. Okay, 5 times 3 is 15 times 3, 45. So it's odd, yeah. Hello?
Yes,
Yeah, it's an odd number.
It's an odd number,
It's
so
always
this one
an
is
odd
correct.
number. Yeah.
Okay. Tell me about the D part.
If an even number
Hmm.
is divided by 2.
Hmm.
So 8 divided by 2 is 4.
Hmm.
What's the quotient? What does that mean?
Oh, quotient is like you are doing 8 divided by 4. 4 times 2 is 8.
Yeah.
So what comes here is the quotient and what comes here is the remainder.
Oh, okay.
Okay. So quotient of always odd or even?
Even.
Even. So the statement is false.
False.
Next, all prime numbers are odd.
Prime.
Three
Yes.
of the prime numbers. Yes. Prime numbers do not have any factors.
No, it doesn't.
It has the one and itself. So you cannot say that they
Oh,
don't
yeah.
have factors. They have only 2 factors.
Okay.
Next, sum of 2 prime number is always even.
Sum of 2 prime numbers is always even. Prime. I'll take 3 and 7.
Okay.
Yeah. It's
Okay.
10, so
When
it's
there is always na, don't stick on one example. Try at least 2 to 3 example and then get your answer confirmed. Like you have taken for 3 and 7. Now try some other number.
5 and 11, 16.
16, it's also even. Take one more. After
Yeah.
3 example, confirm yourself.
17 plus 5, 22.
Yeah. All are even, so it's confirmed. Yes. Next. 2 is the only even prime number.
False.
In the E part, you said all prime numbers are odd. And you said yes, it is true. Now, but 2 is also a prime number and it's an even number. Yes?
Oh, yeah, it's
So the E part is false
yeah, it's
and H part is true. Next.
all even numbers are composite numbers. Yeah. True.
Okay. No, all even numbers are not composite number. 2 is an even number, but it's a prime one. So all are not
okay.
composite. One exception is there. Okay.
Oh, wait, but I thought prime numbers are like 1, 3, 7. What,
1
1,
is
3,
not a
5.
prime number. 2 is a prime number. 1 is neither a prime nor a composite. It doesn't come in any category.
But I thought prime numbers are like 3, 5, 7.
All are
9.
odd. 9 is not a
So
prime
then,
number. 9 is having a factor other than 1 and 9. 3 is the factor. I told you up to number 20, the prime numbers are 2, 3, 5, 7, 11, 13, 17, and 19. Up to number 20, these are our prime numbers. 1 is neither a prime nor a composite. 2 is the only even number which is also a prime number.
oh, okay.
Rest all the even numbers are composite, but 2 is the only one which is prime number.
Okay.
Yeah?
Yeah.
Next, the product of 2 even number is always even.
The product of two even numbers is always even. 4 times
Yes.
4 times 4, which is 16.
Yes, so it is even number.
Yeah, it's an even. Always even.
Don't get confused between even and prime. I think you are getting confused between even and prime numbers. Even number
Yeah.
ending with 0, 2, 4, 6, 8. That are even numbers. Prime numbers which are having only two factors, 1 and itself. So don't mix these. Are 4 different things. Let me tell you it on the board. We have 2 categories. One is even and odd. Another category is prime and composite. Even numbers are those which are ending with 0, 2, 4, 6 and 8, and rest all the numbers are odd. Prime numbers are those which are having them and 1 as its factor, and rest all the numbers are composite. Clear?
So all numbers are composite, and prime numbers is just one. It is if it's divisible by 1 and itself.
Yes. You can
Okay.
write this out. If there is any confusion, just write it somewhere so that you can have a revision whenever you have confusion. In your own language,
Okay.
write it up. That would be easy to understand.
Well, I think English for me is easier because it's my first language.
No, it's like a language. Say, I doesn't mean that in which language. I mean in your own words.
Oh. Oh, okay. 2, 4, 6, 8. Odd. And okay, I wrote it down.
Okay, fine. So is the LCM, HCF, any kind that thing is in your syllabus? Lowest common multiple, highest common factor.
In my syllabus,
Yeah, check it out.
give me.
Yeah.
So lowest common multiple and highest common multiple.
No, it's lowest common multiple and highest common factor. These are the two terms, or maybe it would be by the name lowest common divisor, LCD. Something like that will be there. Just check if it is there, then we will take it up. Otherwise, we will move on to something else.
Place value without decimals, place value with decimals, inequalities, ordering, rounding, estimating order of operation, and simplifying expressions. Transformations and symmetry, polygon measures of motion, organizing data, number categories, powers and roots, equations, angles, bisectors, constructions. No, I don't have it. I don't have it. Hello?
Yes.
I don't have it. No.
You don't have it now? Okay, we are not going to take it up.
Okay.
So now we will do one writing. Fine.
Okay.
Similarly, I will show you a picture and you have to write sentences, not paragraph for now. First, I want to get your sentences perfect. What happened to that thing that your teacher liked that writing? You wrote one thing now? Futuristic something.
Yeah. Yeah, it was good.
That's good. Okay. But I need to work on your sentence formation and grammar also.
Okay.
Birthday party. I think we have done the birthday party. Yeah, this scene today we will do. I'm sharing it up.
Okay.
This one.
Give me a second. Okay. What do I do?
You have to write sentences over it, at least 10 sentences. And this time
okay.
I want you to write not the plain sentences like there is a picture on the wall. Something innovative that what you think about it. Like there is a dinner menu I can see
Miss,
5 p.m. to
can't
9
hear
p.m.
you.
You cannot hear me.
You're cutting out.
Okay, now better?
Yeah, that's better.
Okay. I'm saying I want you to write 10 sentences, but something innovative out of that sentence. Like one sentence, for example, I'm telling the lady at the counter is looking at the pair surprisingly as if she likes it very much or as if she just want to eat it up. Something like that. Not a plain sentence like she's looking at the pair. That's it. No. Something your innovation or something your more thinking has to be added over there. Okay? So start writing at least 10 sentences in 10 minutes. Time limitation is also there. In just 10 minutes, write 10 sentences and send it to me. Start.
Mm. Mm. How much time do I have left?
You are left with 5 minutes.
Oh, 5.
Yeah.
I finished 7 already.
Okay, that's good. Complete them.
I'm done.
Okay, send the pictures to me.
Okay, I'll send it now. One second.
Okay. The boy in the red shirt seems to be cranky for the burger. Cranky or
Craving.
craving? What have you written?
Craving.
Craving. The girl in the yellow shirt at the entrance seems that she can't wait to eat. Seems that, okay, the girl in the, see, no punctuation if there, punctuation if required. The girl in the yellow shirt at the entrance, comma, seems that, no, this sentence is not working. The girl in the yellow shirt at the entrance is very excited. It seems that she can't wait to eat. Okay, complete the sentence. seems to is very excited, and when you have written can't, CAN, then apostrophe should be there because this is the short form of cannot. So can, then apostrophe, then T. The father seems to be ready to eat some yummy food with his daughter. The woman seems to be checking the fruits if they
Turned bad.
sorry,
Turned bad. Turned bad.
Okay, spelling of turned. TURNED.
Yeah.
There is so much food on display, at display, not on. At display, ready to be eaten. Okay, at display, not on. The big picture on the wall shows the fresh food they have. Okay, there are so many choices of food on the menu, in the menu, on the wall, in the menu, on the wall. The hand on the display looks like someone is trying to steal the food. On the counter, there are so many colorful fruits ready to be eaten. After fruits, there should be comma. On the counter, comma. There is a T should be capital of there. There is a basket of newspapers that looks like, because basket is singular. So that looks like they are for sale. Okay?
Yeah.
Okay, fine. So this is it for today.
Yeah.
See you in the next session. Bye.
Bye.